tutorial on BiofilmQ. My name is Eric, and today I will show you how you can calculate different parameters from the segmentation results. The parameter calculation is the third step in the image processing pipeline on the right side of the BiofilmQ toolbox. For additional information on image preparation or image segmentation, please watch our other tutorials. In the Parameter Calculation tab, you can see a list of modules we already included in the BiofilmQ toolbox. Each of these modules can perform a calculation task based on the segmentation results we generated earlier. When you go through the individual modules, you can see a brief description underneath the list. For additional information, you can click on the question mark on the right side and will redirect it to the online documentation on the BiofilmQ website. For a full list of the already calculated parameters, you can use the Data Export tab. Here you can see that due to the segmentation, we already calculated a couple of parameters, like the bounding boxes or the centroids of the single cubes, as well as the shape volume and the time point of each cube. You can filter objects, or so to say cubes, based on the already calculated parameters. For this, you can use the list at the bottom. You will see when you calculate additional parameters in this list that additional options will be enabled. If we want to filter the objects based on the fluorescent property in the segmentation channel, we can use the determine function to list all intensities. By using the crosshair, we can filter out all objects which are below the clicked range. Use set for all to use this property for every single frame on the left-hand side in the files list. Objects which are filtered out are not used during the parameter calculation, even though they occupy disk space. To do this, you have to enable the second item in the list. Remove objects which did not pass filtering. Remove objects on the image border is useful to exclude cubes which are at the edge of the field of view or at the edge of your region of interest. If you want to remove an object parameter, you can use the fourth module in the list. Here you have to type in the module name. If you want a quick overview over all already calculated parameters, quickly go to Data Export. The first four modules are not necessarily parameter calculations. They are more or less modules to modify already calculated parameters or to filter cubes based on already calculated parameters. In order to use those, you have to go through the parameter calculation a second time. The following properties can be enabled in the first go, which we will do step by step. For every module you can select, there's a list of the parameters which will be calculated in the description below. Parameters with the indicator global are calculated for the whole biofilm, not for every single object. So the surface properties include the local roughness, the per substrate area, the local thickness for every single cube in the biofilm. Furthermore, the mean thickness of the biofilm, the roughness of the biofilm, and the outer surface of the biofilm is calculated. The substrate area module calculates the local substrate area and the biofilm substrate area. This is the overlap between the brightest plane inside your image stack and the biomass, which was segmented in the segmentation step. If you don't want to trust our automatic substrate detection algorithm, you can indicate the substrate layer by an integer number in the option field below. Global biofilm properties are properties which are related to the shape of the biofilm. So the height, the length, and the width of the biofilm. And also all other aspect ratios, like the height to length, height to width, length to width, aspect ratios, as well as the base eccentricity, which is a measure for how round the base area of your biofilm is. Additionally, the biofilm base area and the biofilm volume is calculated. The convexity calculates the difference between the occupied volume inside each cube and the convex hull of itself. The distance to the center biofilm is either the distance to the center of mass or the distance to the center at the substrate, which is a projection of the center of mass to the substrate area. For every cube, you can calculate the distance to the surface, which is interesting if you want to calculate, for example, reporter signals based on the distance to the surface. Let's say to calculate nutrient diffusion inside the biofilm. The distance to surface property for each cube is interesting if you fuse the reporter to a nutrient-based function of cells. By relating the reporter brightness to the distance to the surface, you can extract useful information on the nutrient diffusion inside the biofilm. Distance to a specific object can be used to calculate the distance to a specified cube inside the biofilm. To extract a cube ID you want to use, you best create a 3D rendering in ParaView and extract the cube ID from there. A tutorial on 3D renderings will follow soon. The local density calculates the local number density. This is the number of objects in a sphere with the radius given in the option below around the centroid of each cube. The local density is the occupied volume in the sphere as a ratio between 0 and 1. In the fluorescent properties module, you can extract useful information on the brightness of each cube. This includes ratios between different fluorescent channels, the mean intensities in each channel, the mean intensity of the surface of each cube, and so on. We will provide you with an additional tutorial with further details. Tag cells is very similar to filter objects, only that additionally those objects are included in parameter calculation, but they also receive a tag by which you can filter them out for post-processing reasons. The last module is the user-defined parameter. In the user-defined parameter module, you can add your own features to the BiofilmQ program. If you want to start the parameter calculation, just select the properties you want to calculate and click on the Calculate Object Parameters button on the top right side. Okay, now the parameter calculation is done, and you can have a look in the Data Export tab which parameters are now available. This was our short introduction into the parameter calculation. For further details on, for example, the fluorescent property calculation or on the data export and visualization, please go to our other tutorials.